Welcome to part 2 of lesson 4, in which we're going to look at balancing reactions using oxidation numbers. So we can use oxidation numbers to help us figure out what is oxidized and what is reduced in a redox reaction, which is based on oxidation numbers as we just went over, in which an increase in the oxidation number is defined as oxidation. So what this looks like is it's going to become more positive, and a decrease in the oxidation number is a reduction, in which it is the opposite and is more negative. We have a reaction here of carbon solid reacting with O2 gas, which becomes CO2. The O2 and the carbon are both zero because they're both in their elemental state, which, as I said, they are zero, and they become O2 assumed as part of carbon dioxide assumes a -2 charge, and then carbon assumes that +4 charge because we only have one. So what this becomes is this is -4, and this is +4, which is 0. We're only going to go over one example here, and then I'm going to hop onto the next page of notes, and then we'll do maybe two examples, and then I'll leave you to practice sheet 6. Okay. So our example here, when natural gas burns in a furnace, carbon dioxide and water form. Identify oxidation and reduction in this reaction. Okay, so what we recognize this from our thermochemistry unit is a combustion reaction. We have our methane, and methane we said is a -4, and hydrogen is +1. Our O2, remember, it's 0 because it's in its elemental state, and CO2 up here is -2, +4, and H2O is -2, +1. Now let's take a look at our carbon. Our carbon goes from a -4 to a +4. So we go to our acronym, oil rig, oxidation is loss, reduction is gain. Is this gaining or losing electrons? Well, it went from a negative to a positive, which means that electrons were lost. So this is oxidation. And let's take a look at our oxygen. In green. Oxygen went from a 0 over here to -2, as well as over here to -2. What we see is that with oxygen, it is reduced because it gained electrons, and as we wrote over here, reduction is gain. And identify oxidation and reduction in this reaction. That's all we had to do. The other example is done in the notes, so I will leave that to you, and we'll hop on to the next page here. Quick note is, if you're wondering, well, what about hydrogen? Well, hydrogen, went too large there. Hydrogen is a +1 here, and it's also a +1 here, which means that it did not undergo reduction or oxidation. All right, moving on. We can also use oxidation numbers to help us balance redox reactions. Okay, so some of the steps we have to take. Number 1, the first step is to assign oxidation numbers to all atoms and ions and look for the numbers that change. So circle or highlight the oxidation numbers that change. Number 2, specify the change in the number of electrons per molecule. 3, determine the simplest whole numbers that will balance the number of electrons transferred for each reactant. The numbers become coefficients for the reactants. And 4, balance the rest of the reaction like normal. All right. It says the first step here is to assign oxidation numbers to all atoms and ions. So H2O is -2, +1. NO2 is -2, +3. Aluminium is 0. NH3 is +1. Nitrogen assumes a negative charge of -3. AlO2 minus, oxygen is -2, aluminium is +3, and H plus is +1. All right. And what we see is that our nitrogen goes from +3 to -3, in which there are 6 electrons transferred per nitrogen, and there are 6 electrons per NO2 minus, which means that what do we have to multiply to get these equal to each other? Just multiply them by 1. So we can leave a 1 in front there. And then let's take a look at aluminium. So aluminium here, there are 3 electrons per aluminium. All right. So right now what we're doing is we're just step 2, specifying the change in the number of electrons per molecule. And then we have 3 electrons per Al solid. And then step 3 is determine the simplest whole number that will balance the number of electrons transferred for each reactant. The numbers become the coefficients for the reactants. All right. In this one here, it went from 0, and we have to balance that out. So we need to go times 2. So we put a 2 here, put a 2 here, balance the rest out as normal. So H2O2 is 2, and H plus is 1. All right. The other example is already done in the notes, so I will leave you with practice sheet 6. If you have any questions, concerns, wondering anything, contact me and we will help you figure it out. This stuff is actually confusing. It's a little hard to wrap your head around. Once you kind of start to get it, you're like, oh, okay, now I'm starting to see it. Focus for now on the oxidation numbers. Do the watch that oxidation numbers video with that guy Tyler DeWitt, and then do the little quiz, and do that as many times as you need to till you actually start to feel comfortable with it. All right. Take care, stay safe, and we'll talk to you later.